So now let's discuss two very important physical quantities that help us describe our motion of our object that we're studying. So let's look at speed and velocity. Now speed is a scalar, and that's because its formula is distance divided by time. Distance is a scalar and time is a scalar. So whenever we divide a scalar by another scalar, our result is a scalar. So that's why speed is a scalar, and its symbol is given by v, lowercase v. Now velocity, on the other hand, is a vector, and that's because we take a displacement, we take a vector and divide it by a scalar. Whenever we divide a vector by a scalar, we get another scalar. And that's exactly why velocity, which is represented by the symbol lowercase v with an arrow on top, is a vector. So this one has magnitude as well as direction. So let's recall what distance and what displacement is. Distance is the actual pathway taken by our object, while displacement is the most direct pathway that our object could take to get from some point A to some point B. So to compare the two, let's look at the following two examples. In example 1, we have a car that travels 40 kilometers this way and then 30 kilometers down. The entire trip takes 1 hour. So what is my speed and what is my velocity? To find speed, I simply find my total distance traveled, so 40 plus 30 kilometers gives me 70 kilometers. Divide that by the time it took to travel, 1 hour, and that gives me 70 kilometers per hour. What about my velocity? What's my velocity? Well, the magnitude of my velocity I could get from this formula, and I get 50 kilometers divided by an hour. Now, where did I get 50? Well, what's the most direct pathway that this car can take from our point, say A, to our point B? The most direct pathway is actually this pathway. It's a straight line, it's a vector going in this direction. So this distance is what my displacement is. And to find this distance, I simply note that because this is a right triangle, I could use my Pythagorean theorem. So 30 squared plus 40 squared, and the whole thing square rooted gives me 50. So 50 kilometers divided by an hour, and I get 50 kilometers an hour. Now that is my magnitude of my velocity. What's my vector? Well, my vector, my direction, is going this way. So 50 kilometers an hour going this way at some angle, let's call it theta. Now, let's look at our second example. Now suppose I have another car that's going in a circular path, and my car travels exactly this circular distance in a time of 1 hour, where my radius is 15 kilometers. So to find my speed, lowercase v with no arrowhead on top, I simply use this formula and I find my magnitude. So my distance traveled is simply my circumference. So that's 2 times my radius, so 2 times 15 is 30 kilometers, times 3.14 or pi divided by an hour gives me 94 kilometers per hour. What is my velocity? Well, my velocity is my displacement divided by my time. What's the displacement of my car when it travels from this point back to that same point? Well, my displacement is none. My displacement is 0. So 0 kilometers divided by 1 hour gives me 0 kilometers an hour. And that is my velocity. So note that my velocity, my speed, in both cases are completely different.